Welcome all the students. Now we'll discuss about 18th module of the program first year BSc Agriculture Honors for the subject Agricultural Engineering for second semester of course code Engineering 121 and the title of the course is Soil and Water Conservation Engineering. The name of the module is Watershed Definition, Characteristics, Deterioration and Classification of Watershed. I am Mr. Vinod Adkari, Assistant Professor, Don Bosco College of Agriculture, Sulcorna, Kepe, Goa. The outline of this module is watershed, classification of watershed, watershed characteristics, deterioration of watershed. At the end of this module, we are able to learn about watershed, what is meant by watershed, its definition, then classification of watershed, watershed characteristics and deterioration of watershed. Watershed is also known as, we can call it as a drainage basin or catchment area or drainage area. It is defined as, it refers to area drained by a stream in a such a way that all flow originating in that area will come to the single outlet. All the runoff will be discharged to the single outlet. That is the definition of this watershed. Watershed is a hydrological entity in which hydrological cycle gets completed here. Some features of the watersheds are given here. First is the size. The watershed is classified on the basis of its area. So likewise 100 hectare, 200 hectare, likewise we can classify. So we can call it as a micro watershed for small and big watershed likewise. Next is the drainage divide or watershed boundary, we can call it. It divides the area whether the water is flowing towards or away from that watershed. Topography means slope. It refers to the terrain of the land within watershed boundary. It affects the trend of the flow or direction of the flow. Soil types. Different soils are there, sandy soil, clay soils, all types of soils are in that watershed. So it affects the watershed behavior significantly because the sandy soil has more infiltration, less runoff. So it will affect the runoff capacity of that watershed. Different classification of watershed we'll see here. The watershed are classified based on different parameters. 6 parameters are there: size, shape, soil type, land slope, climate and land use pattern. So based on the size, we can classify the watershed into these 10 types: region, basin, catchment and all these. So region having size more than 300 lakh hectare, basin 30 to 300 lakh hectares, catchment 10 to 30 lakh hectare, subcatchment 2 to 10 lakh hectares. Likewise, it is classified in this micro mini watershed. Mini watershed has the area of 1 to 100 hectares only. Second criteria, watershed classification based on the shape. Shape controls because shape controls the time of the runoff to concentrate at the outlet. That is the time of concentration and thus affecting the watershed hydrological behavior. The most common two shapes are there. Fan shape means it is a nearly about circular shape as shown in this diagram. Next is the fern shape, means the elongated long size watershed as shown in this right hand side diagram. Fern and fan shape watersheds. Next, watershed classification based on soil. There are two types of watershed: red soil watershed and black soil watershed. Next is the watershed classification based on slope of land: hilly watershed and flatland watershed. Fifth one, watershed classification based on climate. Two types, likewise humid climate and arid watershed. Sixth criteria, watershed classification based on land use pattern. Three types are there: highland watershed, tribal settlement watershed and settled cultivation watersheds. So these are the classification of watershed. Here we can differentiate the small watershed and large watershed based on some factors. Likewise, first is the size. Small watershed size varies from few acres to 100 acres. Likewise, large watershed which size or area exceeds 100 acres. Next, overland flow. Here the overland flow is predominant in small watershed as they less because the area is less, that's why it's predominant. In large watershed, channel flow is dominant, not overland flow. Channel storage significant in small watershed and here insignificant in small watershed, but it in large watershed channel storage is significant. Next is the land use. In small watershed, it affects the overland flow significant in small watershed, and in large watershed, channel flow is predominant, as we studied already. Then intense rainfall. Intense rainfall cause rapid peak in small watershed, but here in large watershed, it not. Then roughness of soil surface and channel. As roughness creates some restriction to flow of runoff or overland flow, so it affects that watersheds. Next is the watershed characteristics. Different characteristics are there. Likewise, size, shape. Size means based on area we can classify the watershed. Means we can measure the area simply. So we come to know that what is the size of that watershed. Then shape. Shape, we already studied two types of shape: common, fan, and fern shape. Commonly, these shapes are determined by this formula by shape index. It is given by SW is equal to L by W divided by L upon W is equal to L square upon A, where this SW is the shape index, L is the length of that watershed, it is in kilometer, and W is the average width of watershed in kilometer, and the A is the area of watershed in square kilometer. Next is the slope. Slope of watershed is determined from the that map of topographic map we can call of the, and the slope is determined this formula by this formula. S is equal to m into n upon a into 100, where S is the percent watershed slope, m is the total length of contour lines within that watershed in meters, n is the contour interval in meter, and a is the area of watershed in meter square. So we'll determine the percent slope of that watershed by using this formula. For very small watershed, the average slope can be found out by this formula. S is equal to elevation difference between outlet and the most distance reached divided by approximate average length of watershed. Fourth characteristics, the time of concentration. It is denoted by TC. This time taken by the water to travel from most distant point of the watershed to the outlet, it is called as time of concentration. It is calculated by using the nomograph, which is given by Kirpich in 1940. The Kirpich developed one equation. Based on that, we can calculate the time of concentration. The equation is Tc is equal to 0.0195 L raised to 0.77 into S raised to minus 0.385, where Tc, time of concentration, will find in minutes, L is the length of channel in meter, and S is the average slope of channel in meter by meter. Then hydrologic soil cover complex. Here the soil has different characteristics. 4 groups we can classify it into 4 groups: Group A, Group B, Group C, and Group D. Group A, which has a soil have high infiltration rate, so the runoff definitely will be less. B group, moderate infiltration rate, because there is a fine to coarse texture soil are there. In Group A, sandy soil is there, that's why runoff is less. In Group C, low infiltration rate, so the runoff will be moderately high than A and B group. Then Group D, here the infiltration rate of this soil is very slow, means clay or silt soil is there, so the runoff producing capacity is more here in this Group D soil. Next is the cover. Any material can be used for covering the soil surface to protect the soil against rainfall. Vegetative materials are commonly used to cover the soil. These common cover are given here. 9 type of covers are there: fallow, row crops, small grain, then closed seeded legumes or rotational meadow, then pasture and range, then meadow, woodlands, farmstead, roads, etc. So these are the covers. Next is the deterioration of watershed. It is caused due to the faulty use and improper management practices followed in that watershed. So first is the adoption of faulty agricultural, forestry and pasture management. That's why the deterioration of watershed is there. Then fire consequences in that area. Then unscientific mining and quarrying, due to that watershed is deteriorated. Alignment and construction of roads in faulty way, extension of industrial activities, and people's empathy. Bad effects of this deterioration: it reduces the biomass production, it's poor returns from agriculture, grassland and forest and fruit crops, then siltation of reservoirs, lakes, channels, etc., then reduction in water quality and quantity, then creation of poverty in that area. So these are the references. Thank you.